Welcome to my talk. This is GraphQL What and Why. Again, I'm Drew. I work for Oasis in St. Louis. So my background is a view from the top of the St. Louis Arch. I'm assuming we probably have some folks that aren't even from the local area, which is awesome. So we're a little bit what I'm going to talk about today in this talk. I'm going to talk about GraphQL at a high level. So this is going to be an overview of all the features that are kind of the main focus points of GraphQL with some examples. After that, I will show a running API server and some examples of running queries against that server. And then toward the end, there'll be a discussion about sort of the benefits and also trade-offs for enterprise teams, since we kind of focus on that kind of world of development. And then the very last part, I'm going to show some trends from for different NPM libraries that are part of the GraphQL ecosystem. So when I started to make this talk, I wanted to come up with a phrase that kind of sums up GraphQL. And what I came up with is flexible type-safe APIs. So we'll see what this looks like during the talk, but flexible is both in terms of being able to fit the needs of different types of problems, but also flexible in the sense that it has a lot of things in the box that you might not expect from an API framework. And then type safe, we're going to see what that looks like. GraphQL has its own type system, so it hooks in nicely with TypeScript. The features of GraphQL. Well, one of the main ones is that GraphQL gives you a query language. So I've highlighted QL in the name GraphQL, which allows you to ask for just what you need. So we're used to, with REST APIs, for example, having an endpoint for each different piece of data, and that endpoint returns probably a JSON object with a certain shape, and whatever you get back is just what you have to consume. With GraphQL, you get to choose the exact fields that you want in each request, and the server will send you just that piece of data. So in this really simple example, if we have on the server a hero field, which returns an object, in this case, it's just an object of 3 key value pairs, name, height, and mass. In a typical REST API for this endpoint, it would return that whole object. But with GraphQL, we can have our request simply specify that we want the name, and the response will have just the name. One of the benefits that GraphQL's main web page says that this gives you is that you can add fields and types without affecting existing queries. Typically in REST API, that really wouldn't be a problem because you can always have more properties in your object than you're consuming. But I guess unless you're doing JSON validation, in that case, having extra fields would break validation. So you get that benefit with GraphQL. You also get the benefit of less network traffic potentially. Another feature is you can get many resources in one request. So if you're really following REST type of API, and I'm going to mention REST a lot because that's kind of the main point of reference when we're talking about building API servers, especially for enterprise applications. So with the typical REST API, in this example, you'd have an endpoint to get vendors and an endpoint to get products. And so you'd need to make at least 2 requests. That would be 2 round trips to the remote server. With GraphQL, we can put any number of queries that we want in our request, and the server will send back the data for all of them. So that would be 1 HTTP round trip and have just 1 response to parse. So in this simple example, we have vendors is one field that we're querying. We're asking just for the name from each vendor. And then products in this case is a field that takes a parameter. So your queries can have a number of parameters. They can have no parameters as we've seen, or they can take additional parameters. In this case, we're specifying the ID of the product that we want, and the server returns just that. the product matching that ID. And this kind of use of parameters always depends on your server implementation. So we'll see what that looks like a little bit later. But GraphQL gives you the framework for doing this. But it's up to you to write the code that causes this to return the right thing or adopt the right framework that does it for you. So like queries, we can also mutate any number of resources in a single request. So this is an example of mutating two different fields on the server. We are adding a category with the given data. So in this case, instead of an object, they just have split the object into these different fields with their values. And then whenever you have a mutation, you specify what you want back from the server. So in this case, we're asking for the name, products, and the name of the products back from the server. And that's what these additional angle brackets are for. In this second query or mutation, we're deleting a category, the category with the ID of 2. And we're getting back the name of the one that we deleted. So a nice side benefit of this is that if you've set up your API server the right way, or you've adopted a tool like PostGraphQL, for example, that does it for you, you can have multiple mutations in one request and have that one request be a single database transaction. And what that means is that if any of the mutations fail, the entire transaction fails, and then your database would be rewound to the state it was before the request. So you can have multiple mutations succeed or fail together. And that gives you the nice benefit of ACID compliance from the client side, which I think is pretty cool. Another feature of GraphQL, you can access all the types and fields in your API on one endpoint. So with GraphQL APIs, GraphQL APIs are not endpoint based. So REST APIs, the different data lives at different paths on the server. GraphQL is totally different because there's just one endpoint, typically called GraphQL. And you typically do post requests to that endpoint with the query inside the body of the request. It's a little bit more complicated than that. So typically your client, your GraphQL client will do that for you, but that's what's happening under the hood, and that's what you'll see in the network tab. But one of the benefits of that is that you can get the schema definition file. So the schema for the entire API can be represented in one file that's in the format of schema definition language, or SDL. That's just the name that GraphQL has given the text-based representation of the schema. So we have an example here where each one of the fields that we're asking the server for corresponds to a type from the schema. So every GraphQL query, or every GraphQL API has a query type. That's the top level type for the query, for any query. So when we open these initial angle brackets, everything that's available in here is on the query type. So in this example, hero is a field on query, and it has its own type called character. And that's also a type in the SDL. We can see that that has name, friends, etc. In this case, we're just asking for name and friends. And then friends has a custom type as well of character array. And so this everything in your API is based on types and is composed by types. And this propagates all the way to TypeScript, which is great for us as Angular developers. GraphQL is also self-documenting out of the box. Every GraphQL server that most of the frameworks out there for creating GraphQL servers come with Graphical, which is GraphQL's like official interactive web app for querying your API server. It's basically like Swagger Pages, but all in one responsive web app. And because GraphQL has types, it knows about your entire API, all the types in your API, and it gives you auto completion. So we see that on the left here. As you're typing, it will give you suggestions. Um, and you can run your query to see the response, just like you would in a Swagger page. You can do that right in the web app. It also has a search panel for uh, going through essentially the documentation for your API. So every field in your API has optional description field that you can write for it. And you'll see that in this panel. You can search for any field in your entire API. You can click through the fields. So if your fields point to other objects, you can peruse your API really easily with this. You can extend GraphQL as well with what's called an Explorer. So there'll be another button here, which would open a left panel with every single field in your API available in a tree, and you can choose which ones you want your query to have with a checkbox, which is pretty neat too. So this is an example from an actual customer project, which I've obfuscated by blurring, but it's just to show like how this kind of scales out. Um, so apologies for like how unreadable it is, but it's just how it has to be. So this is that Explore panel that I mentioned, showing all of the fields in the API. This is basically our whole API for the project I'm currently working on. And you can choose which one you want because each one has a checkbox next to it, and it will update your query in the middle panel. And then this is like that right-hand side search panel for searching through the API. So you can also deprecate fields easily by just adding @deprecated if you're writing SDL directly. So that's an example here where you can give the deprecation message. And when you do that, it will show up in your right-hand panel in graphical like this with the deprecation message. And GraphQL also gives you tools for tracking usage of deprecated fields. So there's tools for parsing the log and sort of plotting the usage of your different deprecated fields. And the idea is that when they go below a certain level of usage, you can remove them finally from your API. So their concept of versioning is that you don't put everything under a different version endpoint, like V1, V2, and so on. Their idea is that you evolve your API server over time by deprecating fields and then removing them. And GraphQL is also not tied to a specific storage engine. So it's truly a query language for any kind of data that you have. And it's up to you to write what are called resolvers to translate the requests into actual data that's returned to the client. So this is an example on the right of code for Nest.js. Nest.js is a framework for building backend services. And so in this case, I'm using what's called code, a way of writing your API. You use TypeScript decorators instead of writing SDL directly, and Nest will automatically generate the SDL for you. So in this example, the class itself is decorated with this @resolver, and that's telling Nest that this class will be the representation of this piece of our type system in our SDL. So the SDL will have a type of author, and this class will represent each instance of an author. And so to make author available as a field in your query, that's that overall global object that's available at the top level of the query itself. You use @query, and then you specify the return type using this function syntax, and then your function, which can be async, you specify that. So in this case, the field in your query in your SDL will have the name author because it uses the name of the method by default as the name in your SDL. And we're telling Nest that it should take an argument with the name ID, and the type will be an integer. And so yeah, GraphQL has its own built-in types like int, for example, which in TypeScript we're going to have to use number. And we simply return the data that should come back whenever the author is requested. And because an author has also a posts field, then we need to resolve the field as well. So this is how you resolve a child of the author object. So this is just an example of writing your own resolvers. You can also adopt a framework that will generate resolvers for you and extend that generated schema. So one example is PostGraphQL, which I mentioned briefly earlier. That's a tool that you point the framework at a Postgres database, and it generates all the create, read, update, and delete parts of the schema for you. And you can extend it with plugins, which allows you to do other things beyond simple CRUD mutations and queries. So it's a pretty flexible tool. It's basically Express middleware, although you can also mount it with the built-in HTTP library that's part of Node.js. So it doesn't require very much extra steps to add to a Node project. Another one that's a larger project is Hasura. Um, it does what PostGraphQL does, but it also supports other types of data stores. It supports many different databases. It even supports pointing your GraphQL API at another REST API and bringing that into your overall GraphQL API. It's a very different animal than PostGraphQL. PostGraphQL is backed by um, basically a couple, and they're the main force behind the project. Hasura has a lot of VC funding and is a really much larger effort. To bring that into your project, you need to deploy a Docker image, so it's a little bit of a bigger thing to adopt, but it has its own web interface for configuring it. So those are two interesting things. I've personally used PostgreSQL a lot, which I'm using on the project I'm on right now. Um, and, but in general, and the most popular way so far, because a lot of people have created their own APIs from scratch, is to write your own resolvers. And it looks something like this, although it depends on whether you're using Nest or some other framework. You can create your own API, GraphQL API from just the GraphQL npm package as well. It's just that you don't have some of the nice features that a framework would give you. Another feature of GraphQL is that you can subscribe to server events. So it has built-in pub sub, which is also something that you might not expect from a general API framework. So what that looks like is you can write subscription in your GraphQL query, and so this is what you'd send to the server. You can give it a name, and then inside you can subscribe to a field. So here we're subscribing to current user updated, and we're asking for the user and event fields from that event. And then another, in another instance of a client, so you could do this in graphical even, you can cause a mutation on this. So we're going to update a user by ID. In this case, I guess the current user is ID of 27. So we're going to update the user by changing its name to foo. And that would cause this to emit a new object with the user and event for the latest value of this current user. So again, this is built in. It depends on whether your client and server support it. The most popular client is Apollo Client. So for front-end apps, most of the time, pretty much all the time, you're using Apollo Client, which supports subscriptions out of the box. And the most popular server is Apollo server. So most of the time you're going to have access to subscriptions. There's a much smaller library for creating a server that you can use called GraphQL request, um, or a smaller client that you can use called GraphQL request. That one doesn't support subscriptions, but so it depends on whether your client supports it, but it is part of the GraphQL spec. Another feature, and this isn't part of GraphQL itself, it's a part of Apollo, is that you can merge several GraphQL APIs into one using what's called a gateway. So um, that result is that your client can make all requests against that one gateway server. Um, it even supports allowing your microservice that's being federated to reference fields in its queries that exist on other services. So like inventory services, SDL could reference fields in reviews service or product service if you set this up in the right way. Um, there are some caveats to Apollo Federation. One is that it doesn't support subscriptions. Um, that's supposed to be fixed or improved on in Apollo Constellation, which is supposed to be the next incarnation of Federation. And that hasn't landed yet. They're working on it right now. Another downside of Federation is that each of your services has to be configured to support Federation, so it requires some config on each service. That's another thing that they're supposedly not going to require with Apollo Constellation. With Constellation, it's supposed to be possible to point it at any GraphQL API to federate it under a gateway. So I personally started out with, we have actually three GraphQL services, and initially started with Apollo Federation to have this gateway, so we have just one GraphQL endpoint, and we can make all our requests there. But because it doesn't support subscriptions, and it seemed like something we're probably going to need, and we didn't need to reference fields on other services, I've changed that to be using multiple Apollo clients. So in Angular, you can have multiple Apollo clients, each one with a different name, and in that way you can still use multiple APIs. They're just not merged into one. But hopefully Constellation will improve on some of these things. Another really neat feature of adopting GraphQL, which I like a lot, is that you can generate your client Angular code and TypeScript types directly from your server SDL. So what this looks like is something like this. So this is a really simple GraphQL API that's built with Nest.js. This is actually just the resolver for the API, but it's the most important part for the example. In this case, there's just going to be an author's field on the query, and that's going to return this array of objects, and type for the author is specified with decorators up here. And so in your client, for example, in graphical, you would write this to get all the authors. What you can do is you can have a file that's called a GraphQL file that's going to be written in the query syntax just like this, and put your queries in there. And then you can pass that file and the SDL file for your server to what's called to a tool called GraphQL CodeGen, and it will output a file that's like this. It's actually longer because it also includes the TypeScript types. This is just the part that corresponds to the service, but it will generate all the services that your queries need to get the data in the client. So this service is going to represent that author's query from the last slide, this here. And earlier in this file, there'll be an author's query type and an author's query variables type. And you can generate this file in your Angular application, and anywhere you inject it, you can call .watch on this service or .query if you just want a one-off query. And you'll have the data with full typing right there. This is awesome because any breaking type change on the server results in an Angular compile error automatically, as long as you have run GraphQL CodeGen. And that's great because we want to catch type errors at compile time. We don't want to wait till runtime to catch them when things break and we have to have bug fixes. You can go even further than this, though, and this is what I've done on the project I'm on right now. You can go all the way from the database to the Angular application. So in my project right now, we have a Postgres database, well, actually several. We point PostGraph file at the database to introspect the database and automatically creates the GraphQL API that includes any kind of custom fields that we've defined in our plugins. And then we can export the schema SDL file and pass it through GraphQL CodeGen. And all of the Angular services and TypeScript types for the GraphQL API are generated automatically. We can run this anytime we make a change in the database, and the changes flow from the database to the Angular app. I think this is pretty neat, a pretty neat thing to use. And we're hoping that it will provide a lot of benefits as the project grows. This isn't something that I've come up with. It's something that has been desired for a long time. This is just an excerpt from a popular post that Netflix published after they adopted GraphQL, where they said that they would ideally like to have type safety from the database all the way to the client. And again, this is actually possible today with GraphQL CodeGen in particular. To get the SDL file, the server will typically have a method you can call to export the schema as SDL. And if it doesn't, there are tools that you can point at your GraphQL API, any GraphQL API that's running, and just grab the SDL that way. Since since GraphQL servers have to publish their SDL in order for the clients to use them. All right, those are the features, kind of the high-level features of GraphQL. This is going to be a little bit of a discussion about the benefits and trade-offs compared to REST. So it's a bit of an apple and orange comparison. So I've put the apple and orange emoji here, since they're not exactly the same approach to building APIs. But typically, you're choosing an API technology to adopt. So you're typically going to be comparing GraphQL at least to REST. So with GraphQL, as we saw, we can catch type errors at compile time. This is a really nice benefit to catch more bugs before the application is deployed. And you get that you can get that by using GraphQL CodeGen on your API server, as we saw in the first example approach with Nest.js as the example. But you can, if you wanted to, go all the way from the database to your client. Self-documenting out of the box, so you can put your description for each field in the SDL, or if you're using a tool like Nest, you can put it in where the fields are defined, right in code, and you can label them as deprecated and so on. And Graphical will automatically pick that up and show it in the tool, so you don't have to generate Swagger pages. Your schema is the documentation for your API, and any tool that you point at that schema that parses it will be the documentation for your API, and that's pretty nice. A lot of the benefits that people talk about with GraphQL are around the tooling that GraphQL has. So this is just an example of that. It makes like the developer experience pretty nice. GraphQL is also pretty flexible when your requirements are evolving. So you don't have to think real hard about how exactly you're going to represent your data like you would with REST. If you're strictly following REST, then you want to figure out, your representations. You want to figure out what the layout of your endpoints would be for the different representations for your data. and then how your client is going to query them. Because typically, if you have nested uh, objects within a higher level object, then you'd have to make the initial request to get that top level object, which would point to other representations, and you'd make more HTTP requests. So you have to think a little harder when designing your server with REST than you do with GraphQL. Whenever requirements change, you can just change which fields and types are available, and the tools will kind of respond to that. GraphQL has built-in pub subs, so you don't have to add a WebSocket API on the side or a server-sent events API on the side. It's built into Apollo, and um, you have that available if you need it. Each request could be a complete database transaction, so this isn't really possible with REST because you have to make multiple requests. With GraphQL, because we can make one request, we can write our server in a way that keeps ACID compliance. GraphQL solves the over or under fetching problem. That means that we don't have to request any more data than we need, and we never end up in a situation where we've made a request but didn't include everything we needed, so we had to make more requests, which happens all the time if you're following REST pretty strictly. This can result in less network traffic, which also result in less round trips, which makes your app more responsive. GraphQL is also a bit closer to SQL because both of those are a query language. So there's a little bit less of what some people call an impedance mismatch between your API technology and the way that you're querying your database. So it's just that much easier to go from your database representation to your API. And GraphQL has a pretty good developer experience thanks to the tooling that surrounds GraphQL by this point. Some of the benefits of REST are that it requires less tooling to get started. And I say requires because you can, if you build out a complex REST API, it's going to be at least as complicated as a GraphQL API. So if you have like a framework that's generating your REST API, like Spring, and then you're bringing in all your Swagger pages and all of the files that you need to define all of the tooling, then you'd have just as much overhead. But to get started with REST, all you need is something as simple as an Express server. Endpoints are easy to write and use. So people, developers and people that are used to the web, are used to asking for resources at different paths, and REST follows that directly. So it's pretty easy to think about. Putting each different piece of data available in the handler for each different endpoint is pretty straightforward as well. You don't have to think about, should I be using @resolve field? Should I be using @resolve? And you don't have to make, you don't have to think a little, you have to think a little bit harder when you write resolvers, I think. With REST, the browser can also cache responses using the built-in cache. Since it's using HTTP to simply get the representations of your data, you can leverage the browser's cache any way that you want. I put an asterisk by this because people often say that GraphQL requests and responses can't be cached because they're always post requests. That's not really true. You can make GraphQL requests as GET requests. It's not very common to see, but you can do that. Apollo supports it. The downside is that your query has to fit in the length, the maximum length limitation of query parameters in the URL. If it exceeds it, you can make a named query on the server that your client just calls. So you can kind of get around it. But in general, you're using the post endpoint with GraphQL, in which case you're not caching in the browser's cache. Apollo client, though, does have caching that it's implemented internally, but that's on the JavaScript side and not the native browser cache. With REST, you have a little bit higher visibility in the built-in browser your dev tools, that's because each request is going to show up under a different path with the correct HTTP verb, like get, put, post, delete. And you'll have the error, the error code right there if there's an error. So because it's built on top of the way that web pages are fetched, then all of the tooling around that applies perfectly for REST. So it's just easier to open up the dev tools and see the names of all the requests coming through, and each query essentially is a different entry in your network tab. So it's just a little bit easier to read. With GraphQL, every single request is /GraphQL, and you have to click in to see it. Now there's extensions you can use that make it a little bit nicer, but like browser extensions, but the native built-in tool it's not quite as visible in that. REST is widely compatible on pretty much everything that consumes an API is going to support plugging it into a REST API. If you're using some if you're using a language that's not commonly used in the web, then you might not have a GraphQL client or server implementation for your language, which then you'd have to be writing a GraphQL client or server yourself. With REST, I would pretty much every language is going to have a library to build a REST API with. REST also has really strong conventions to follow by now. There's open APIs, the good example of that. That's like the new name for Swagger. So if you just follow those conventions, you're going to succeed pretty much with building your API, or you'll at least have something to point to justify why you made certain decisions. With GraphQL, it's still a little bit less like standardized around exactly what conventions you follow, but it is more opinionated than than some. So you have the benefit of following a more opinionated approach to building APIs. REST also has many more competing frameworks and vendors. So with GraphQL, I mentioned like Apollo is by far the most popular client and server library to use. There really aren't very many good alternatives. I mentioned GraphQL request, but that one's not even really competing with that. So you have a much narrower field in terms of competing frameworks than you do with REST. With REST, you have a lot more variety. And REST, a really big thing is REST supports all MIME types. So that means any kind of type you want to send back to the client or post to the server even, you can support that. The MIME types refers to the actual type of the data. With GraphQL, you have to have everything in JSON, which means that you can't return like binary or images or things like that in a GraphQL API. So that's a bit of a downside. If you search like for solutions, you'll find people that have like hacked the Apollo server to, on certain queries return, a different type to the client to get like more like binary data back to the client. But by the time you're hacking the framework to do what you want, it's not supporting it, essentially. So that is a big benefit of REST. And the last thing I wanted to show is current trends around different GraphQL packages. So I kind of wanted to look at like comparisons to kind of get an idea, because the raw numbers with NPM downloads per week is not very straightforward to like learn things from, because they can be influenced by so many factors. But I think comparing the different downloads per week can be insightful. One thing I noticed is that 18% of the downloads per week of Nest.js GraphQL is 18% of Nest.js core, and it's been consistent for the last year. If you go back 2 years, it was like 9%. So there's stable. It looks like there's stable and solid adoption of GraphQL when it comes to Nest servers. Now it doesn't appear to be a growing share of Nest servers using it, so it's not like exploding in popularity. If it were, then we should be seeing this number going up. But there's definitely stable adoption at this point. Nest.js is, not obviously not the way that the vast majority of people that are building GraphQL APIs use, but it's a way that I found to like compare, building a RESTful API to building a GraphQL API in terms of use. Since every Nest server is going to have a Nest.js core. In the right-hand side, we have downloads per week of GraphQL itself. That's the NPM package for GraphQL. And also Apollo client, which had a name change. So I'm adding the two together for V3 and earlier. And then also GraphQL request. So we can see that year-over-year growth of GraphQL is pretty high. It's actually higher than the front-end frameworks. So we can see that the growth of GraphQL package is exceeding the growth of the front-end frameworks. So we can safely say that that's kind of going a little bit faster than just, it's not being generated, like the growth is not being generated simply from growth in front-end. But if we look at like Apollo client, then we can see that that it's pretty much in line with the growth in the front end. So it's probably being driven by that growth, just like Nest.js core is driving the growth here of GraphQL for Nest servers. So it at least has like stable adoption, but it's not like, oh, go out and build every API server with GraphQL. You want to, at this point, I would say, want to decide if GraphQL, the benefits of it, are going to benefit your use case. And if it does, then it can be pretty powerful. Another just interesting side note here is GraphQL request has pretty high growth compared to Apollo client. I'm not quite sure why that is. I noticed that there are a ton of like Hello World apps on like GitHub that use it. So maybe a lot of people are learning GraphQL by using that, because you can just drop that into a Node script and start making queries against an GraphQL API. It might also be used in microservices to make requests to other services. But I thought that was a little bit interesting because Apollo client you would just assume is what everyone's using, but there's by now 1.2 million downloads per week of GraphQL requests, which is quite a lot. And we can see that a framework that's really taking off would look like this, Nest.js core, 300% year-over-year growth. Nest.js has become really popular recently. So that's what it would look like if something was like really taking off. All right. That's my talk. Thank you for coming. We'll take any questions now.
A question about indexes. So if you've got some tables that are, a million records in it, how do you tell GraphQL not to let someone search on a non-indexed column?
Not to search on a non-indexed column.
Yeah.
You're saying that you want to make it so that only certain columns can be searched.
Right.
That's up to your implementation of the resolvers. So, like your resolver is what's responsible for doing the SQL queries to your database. So you'd want to write your resolver that way. With something like PostGraphQL, there's plugins that give you the ability to filter, so it'll automatically generate the SQL for you. In which case, all of the columns would be filterable. So with that, most of the other parts of the framework, the PostGraphQL framework, let you use what's called smart comments in your database to turn off features. So there might be an approach like that that would prevent certain columns from appearing in the filters. But in a general API, like a general GraphQL API, you're the one responsible for implementing that part. So GraphQL doesn't really have much to say about it. It just gives you the ability to pass params in your queries. In terms of limiting the number of rows, which I don't think was quite the question, but you can limit the number of rows and specify which ones you want using GraphQL has a built-in cursor mechanism. So you're supposed to use that to specify how many rows you want after a given row, and it uses it uses its own IDs for rows to support. Like if you're making a query for another chunk of rows and some rows were added or deleted since you requested the last chunk, the cursor is supposed to help you get the right rows back in those situations. Um,
Okay, thanks.
I've got a question.
mhm.
So you had said that like the combination of GraphQL, then like the client library, then like Postgres file, whichever, could potentially save a lot on an enterprise project. Like how big could that plausibly be? Like, are you saying that somebody could adopt this, then just like, get rid of half their team or something? I mean, is it that big?
Um, I mean, there's different aspects to that. So there's like how much code you have to write and support, and there's how much work you have to do to think about how to organize your API, um, and things like that. Like just the fact that you can set it up so that you have type safety end to end would eliminate an entire class of bugs that I've seen constantly in enterprise development. Like, so when either you or somebody else builds the server, and then the client has its own idea of what the types are that each endpoint returns, and things are in flux, and so things change and then they break in production. Those kinds of things should be possible to eliminate by having this end-to-end typing that GraphQL can let you do. You can achieve end-to-end typing with REST too, but you'd have to set up a whole bunch of tools around it that kind of come out of the box for you with GraphQL. So I think like a lot of the benefit I would say probably doesn't come from building the API itself. It probably comes from like the problems that can arise along the way as you scale.
So like if a project has like how big should a project be before somebody should go take a serious look at this?
I don't know if I would think about it as how large a project is, because GraphQL will give you benefits right away. But I think to me it depends on like whether your project looks more like a data project where the shape could be changing a lot, or it could be pretty arbitrary, um, versus we know exactly what all the data is that we need to support. So in that case, it's really straightforward to organize your data as representations in a REST API. So I think to me, it's more about the shape of the problem. I would think that like big data type projects would benefit a lot from GraphQL because of the fact that you can specify the entire API in sort of a JSON shape, and then it's kind of up to who are writing the resolvers to support the querying. Um, so to some extent, you can have like your backend team and your front end team kind of not working quite as closely as they need to be if you're working in a REST environment, because you can have the backend like, here's a whole bunch of data, make this available as an API, and if you just do that with GraphQL, the front end team can just select which things they need from the API.
I have a couple more, but I'm going to be quiet, let other people ask questions.
I have a question on the generated services. So you said it generate the services, and then a lot of times you'll have some custom mapping on the front end, and sometimes it would go in those services, sometimes it go other places. So I'm assuming that would be overwritten every time the service was regenerated, as far as like from an Angular perspective. So is the idea that you just set up GraphQL to map it how the front end needs it from the get-go, and then you don't have those changes you'd make to the generated services, or you just have another service called the generated one to do whatever mapping you need to happen?
Yeah, I would say the latter. Like you'd have your own service that's consuming the generated services and do the mapping in there. And typically, like the changes that'll happen when you regenerate the generated file is going to be like name changes to the service. If someone changed the name of the field in the API, then you just update the names in the one place that you're using it, which is that service that you've written. Or if the shape has changed, again, you just have that one service. So I wouldn't take that generated file and import it all over the place in components, because you know, whenever things change, you're going to need to make updates to all those places. But it at least eliminates the copying of types and having to write the Apollo services, because it does that for you. So, but yeah, I would have a service in between. That's what I'm doing right now.
Okay. And did you convert from CRUD, or did you start, was this a new app that GraphQL was picked for?
We started, so we didn't have to like, you know, rework a REST API as a GraphQL API.
Okay.
So I guess I don't have a ton of insight into that process, but the fact that GraphQL is so flexible in what kind of shape the data that you want to provide, I don't really envision there being too much of a problem converting a REST API to GraphQL. So I wouldn't expect that there would be much problem, but I haven't done it myself.
Okay, thanks.
So you had mentioned being in a project that was using this from the beginning. Are you aware of anybody who's like adopted it midstream, and like how did that go? Like, I mean, I can imagine it being like hard to let go of the low-level code from REST. Like, have you seen or talked to anybody who's done that?
I don't, not off the top of my head. In a previous project, we've gone the other way because it was a lot earlier in the history of GraphQL, and the backend was a very legacy code base, which didn't. It was going to be a lot of work to support GraphQL, but I don't really have, unfortunately, I don't have a lot to share about converting from like a REST API to GraphQL.
Anybody else with any more Q&A? Well, we usually applaud our speaker, so there's no, if anyone wants to unmute and applaud, please do so. We kind of missed that since we're not physically in a room. Normally, several of us typically will hang out for a little bit after the end here, just for any kind of random Angular chatter. And certainly if anybody wants to say, oh, wait, I thought of something else to ask Drew, yeah, hopefully he can stay for a few more minutes also. But any closing words, Drew?
No, it's just thank you guys for coming. And I mean, I've really liked GraphQL so far, so I definitely like it a lot. But yeah, there's definitely things to consider. So
Cool. Great. I'm waiting to see if anybody has any generic Angularisms. We just upgraded our Angular teaching to Angular 10. That was nice. I don't think we had to change any code. I think it was all still compatible after the upgrade. Anybody else upgrade anything to Angular 10 yet? See if anyone will admit it.
So I have a question. If you are new to GraphQL or React, how to get used to the syntax? Is it by the practice only, or like I am more of a Java developer so far, but trying to get my hand into these. So is it more like taking courses and doing practicing?
It looks like maybe Drew's connection dropped. So unfortunately, he was the GraphQL guru. Oops. Has anybody else here used GraphQL enough to try to help with that question while Drew gets his computer back up and going? Oh, okay, Drew is back. Could you repeat your question for Drew? He was away because of a technical glitch of some kind.
Yeah, hi, I'm Deepthi. So to get used to the GraphQL syntaxes or React syntaxes, what is the best way you recommend? Because now if you go to Google, there are so many courses from so many places, which will be the like quickest and easier way and the best way.
Sorry, the best way for learning GraphQL or for learning React and Angular?
I know Angular, but I have done Angular 2, but not any higher versions. So yeah, React and GraphQL, maybe I would say those two. Um,
Okay. Well, I guess a few things. So Angular, since 2 hasn't changed very much, they try to make the API really stable. They've mostly added features. So you're probably more up to speed in Angular than you might imagine if you know Angular 2. But for React, I would say start with the React tutorial. They have a tutorial that's split into two methods of learning. One is by example and one is by kind of more like a textbook approach where they explain all the concepts. So that's generally the starting point for React. And for GraphQL, I would for that I would actually kind of just skim the main page for GraphQL and then start playing around with it. And a really easy way to play around with it was with PostGraphQL, which I really wanted to show, and I kind of, since it wasn't in the slides, I forgot to show that. But you can point it at any Postgres database, and it will just make an API for you. So that's one way. There's also um, websites where they have like GraphQL playgrounds. So that's like a web app that has the query box to enter your queries, and it'll run against like a fake server that they've created, so you can get used to GraphQL queries and mutations that way. I've used a few of them, and they're pretty nice. Um, in terms of writing the server, you'd want to learn Apollo server, but you'd typically want to kind of if you're adopting a framework like Nest, that's what I'm most familiar with. They have their own docs for creating your GraphQL server. So Nest has its own GraphQL library that internally brings in Apollo server, so you're not using it directly. If you want to learn how to use Apollo server directly, they probably have at least a tutorial somewhere. But for the front end, for front-end GraphQL stuff, you definitely want to use Apollo client that's published for your front-end framework. So Apollo client has in its docs, most of it is written for React, and then there's a separate library for Angular. So you want to pick the one that's for your framework and go with that. Yeah, but for learning the query syntax itself, there's pretty nice like playgrounds available on the web to try it out, or you can use something like PostGraphQL. Let's see, how many folks do we have here?
sure, thank you.
Yeah, there's still 11 here, so if anybody else queuing up questions, and we'll take general Angular chatter as well, of course, any more GraphQL.
Yeah, I can also show the demo that I had if folks are interested.
Yeah, if you think that, especially if it might spur any more questions.
Yeah, that's a good point. Let's see here. All right. So for this demo, I'm using PostGraphQL to point to auto-generate a GraphQL API pointed at a database I created. And I just created this database and populated it. I haven't populated it with anything yet, but I'll use the GraphQL API to do that. The easiest way to start a PostGraphQL server is to use npx PostGraphQL. So npx is going to npx is a way to run any npm package without like npm installing it to an actual project. So it'll use the npm cache on your computer and just download the module for you and run it. So it's going to run PostGraphQL. PostGraphQL has a CLI wrapper, so that's what this is doing. In general, you'd use PostGraphQL as an import in your node project. So I'm going to point it at the database GQL talk that's running on my local Postgres instance. And actually, I'm not using the first one, so I can remove that. So I'm pointing at the local instance, and I needed a username and password, so I'm specifying the full path here. And this is the name of the database. And I've turned on subscription simply because that also adds the Explorer to the left-hand panel. So I'm not actually using any subscriptions. To have subscriptions in PostGraphQL, you have to write your own plugin. So it's beyond this demo. And then it will be available at localhost 5000. So I'll just start this server like this. I'm surprised it wasn't cached, so oh well. I just ran this before, but so it's available on 5000. That's what this is. So if I refresh, this is the interface, the graphical interface. And it's already populated this panel because it uses like local storage for saving the last query that you did. It also saves the history so you can go back to other queries that you've already made, which is pretty great. You can see that you can put multiple things in here, like multiple queries and mutations, and then you get to choose which one you want to run when you click the play button, which is also pretty nice. You can set your own HTTP headers, so if you need to like have authentication in order to use the API server, you can just specify your bearer token in here, and it will apply it to each request. And the Explorer is available over here, where you can choose which parts of these things that you want, and it'll add them to your query automatically, which is pretty slick. And you can just see all of the fields that are available to you in there. So if I start, I'm just going to query all people and all talks. The database I set up is like representing Angular lunch talks. So we have a talks table and a people table, and talks has a speaker that points to a row of in the people or a row in the person table. So if I run count, it'll return the count. And PostGraphQL gives us a total count field on every collection, so we don't have to get all the data to count them. We can just ask for the count. There's nothing in here right now, so I can run a mutation to create a person like this. I've split them into two, the mutations, because I need to know the ID to create the talk. I tried to find a way to do both mutations in the same request and then use the returned ID for the second mutation, but I didn't see a way to do that. So I'm going to do them separately. So I'm going to create a person for myself, and I have it created in the database with the ID of 7. This is generated by Postgres, and I put this data in that person row, and then I'll create the talk using that person. So I'll specify the ID for the speaker, which is 7, and then I will run that mutation. And now I have a row in my talk table. And so now I can query the talks, and in here, because the talk points to a speaker, I can actually get the speaker right in the data, and PostGraphQL does this all automatically for me. It generates the SQL to do this. So if I run all talks, now I get that talk row with the embedded speaker return inside it as well. So you can do this with just a single instance like this, or it could be collections, any kind of composition, and it's using the Postgres schema to figure out the relations between the tables. So it knows that person is a foreign key on the talks table. So this is kind of just showing how to use graphical and how to run these kinds of queries. But it's obviously also plugging PostGraphQL or PostGraphQL a bit, because I just think it's pretty slick. It doesn't have very much adoption yet, and I think that's probably because they don't have very good developer relations, being just a couple that are working on this project for the most part. But I think eventually, if Hasura succeeds, they'll also have a lot of share of the market too.